Hello there. Today we'll be doing Neetcode number 7, minim stacks. In this problem, we'll design a stack that pushes tops and retrieves the minimum element in constant time. So this is immediately. So we'll rely on the structure of how stacks work to get the minimum item. If we retain the minimum item up until a certain point, then we'll keep that minimum item. So here's what I mean. So say you have 4, 3, 2, and 2, and 1, and 3. So our minimum number here is 4. Our minimum number here is 3. Our minimum number is 2, 2, and 2. Suppose we remove the 3. That's fine. That means we remove these two. Remove the 2, that's fine. Remove the 2 again, and now our new min is 3. And we remove the 3, our new min is 4, and remove that, we have no more minimums anymore. So the minimum, if we take the min of the entirety of this current stack, we will get the minimum at that particular point. And by removing the item, we'll also, we don't need to update the minimum. So the minimum is practically glued to our current stack item. So we're going to use a tuple to get this problem. So first of all, self.stack is equal to empty array. That's how we initialize it. And when we push if not stack, then we're going to implement this differently. So self.stack. Self.stack.append. We're going to append the current value, and the minimum value is going to be the current value as well. So we're going to append 2 values to it using a tuple. Also, else, then we do have a stack. Self.stack is going to append the value and the minimum value. So the minimum value of get self.getMin, or min, the current value. So we'll find out what the minimum value is up until that particular point. So next problem is if not self.stack, what happens if we pop? We don't want to do anything, otherwise let's pop. So let's just pop the next item. So self.stack.pop. Okay, all good? So let's get the top of this item. If not self.stack, return none. I don't know if we can do that, but so then otherwise self.stack, the most top item, take the value, which is 0 in our tuple. If not self.stack, return none, because there's no number in there. Otherwise, self.stack, we're going to take the -1 and the first item, which is the second item here. And that's it. And that's how we do this particular problem. For this particular part, we can also use top to get our minimum number. It's all the same. I guess it creates less confusion. Maybe that will make more sense. Because we're constantly updating our minimum number every time. Oh, we have an issue. Okay, let's see. What does it say? None, none, none. Oh, not self.stack, not self.stack. Oh, let's see what the heck happened here. Are we doing this properly? Oh, I see. Return. Run code. And voila, perfect. And this way we kind of handle errors and everything. Like if the stack is not available, we're not going to pop nothing. If there's nothing in the stack, we won't, error out of bounds, that type of issue. Yeah, and that's all for this particular problem. This is, you could also use 2 different stacks. I think that use the same amount of space. I mean, it's just, So that's all for this problem. I hope you learned something. If you have any questions, comment below. And if you enjoyed the video, like and subscribe. If you want more videos, check out the link in the description below. And thank you very much for watching.